Okay, so as you've learned, this is already not enterprise code signing. We're actually going to be mainly talking about one larger topic, which is controlling your tools. But we're going to try and cover that through a narrative of the last 10 years of my experience building apps on the Mac and on iOS. So where should I start? Well, start by explaining who I am and how I got to the position that I'm in. My name is Orta Therox. I do a few things, one of which is I work at a company called Artsy. We make it easy to buy and sell fine art online, but a lot of people know us from our work in the open source realm, where we have a concept called open source by default. So a lot of people in the iOS world have seen that our apps are available for other people to download, explore, and they can see the process in which we build these things. I also work on a tiny little project called CocoaPods. Currently at 1.2 million apps use CocoaPods, which is a big burden to carry all the time. But luckily for me, Apple will be taking that with Swift Package Manager soon. Woo! And I also work on another interesting project called Danger. And Danger is a system for creating cultural unit tests. So we use it mainly to be have you done a changelog entry on every single pull request? But they can get very complex. And one of the things that I'll go through here actually shows one of the kind of rules that we use with Danger to make our life a little bit easier. So this story starts a whopping 10 years ago. And that's how long I've been doing Cocoa Dev. Effectively, it starts with my first real Mac application. This application was for my university final project. We call those dissertations in England. And part of the dissertation that I had to do was I had to write some software, and then I had to write up about how I built it, what code choices I made, and the usual kind of thing that you would do for a university project. So what I did was I wanted to generate an app for me as a musician. I was in a band at the time, and I wanted to handle the set list management. So showing lyrics on a screen, pressing play to play a backing track, and being able to manage those resources. So what that ended up being was this beautifully designed thing that you can see to the side here. And I generally call these kind of apps CRUD apps. It's a database terminology, but it basically means that you have these resources, you create them, you read them, you edit them, you update them, and then you destroy them or delete, whatever you want. And basically, the interesting part about this entire dissertation project was that I got all the way to this point here with absolutely 0 lines of code. And I had a fully working version of my application without having to do anything at all. Well, I mean, obviously I had to do a ton of stuff in Interface Builder, but in terms of things that were long-term maintainability and actual application-specific code, I didn't have to do actually that much. I went and downloaded the source code in preparation for this to try and get a sense of what I actually had to write, and it was only over 3 domains. It was handling dragging and dropping for reordering songs, playing background music, and then loading interface files from files. Which, when you're doing a dissertation where you're meant to talk about the code and the choices that you made and how you got to this point, it makes it very difficult to actually start writing about the things that you've not done. And so, I'm going to quote myself verbatim. The original brief had no concept of unconventional instruments which came in by user requests, and I was the only user of the system. So what ended up happening is, TLDR, I couldn't talk about any code because I had wrote no code to do in my dissertation. And this was worrying for me at the time because I actually had this problem of I need to write about something. And so the first thing I did after actually writing the software was rewrite my dissertation on the idea that how did I get to a point where I didn't have to write so much I didn't have to write so little code in order to actually do an application that is the sort of thing that a lot of people are building at the time for the Mac app. And so what I ended up doing was just expanding the scope drastically. I added an amazing feature. I added the ability to use Guitar Hero controllers into the actual app at the same time as running it and use them as musical instruments. And so it talked a lot about like how the C code that manages that is very different to like the Objective-C code that was just used for like loading nibs, as well as talking about like the different types of abstraction layers that you had between them. And this is interesting because I came in expecting to build an app that would require a lot of code, was like something that I could talk about and could write about for something that like I cared about a lot, because everyone cares about their degree when they're on the third year. And I was really struggling at the time because the tools were so well built for actually the types of jobs that I was doing, which was creating these apps that were specifically for handling some small database thing in core data, making it easy to edit and update and change these like CRUD resources, in this case the set list. And so I struggled with writing, and the best quote that I could find in my dissertation about this problem was that writing Mac OS X software at that time was extremely like high bar to entry. In order to actually understand the entire code base, which, as I said, was tiny, was that you needed to understand almost every single part of the system in order to do it. So you had this like high barrier to entry, but at the same time, the actual amount of domain-specific code was tiny, and the actual apps that you could ship with were pretty reasonable, all things considered. And so I felt a lot like, at the time, and it still is, building Mac applications that are built for editing resources is still something that like all of the tooling that we have nowadays is still very, very optimal for. Whew. Okay, so that was 10 years ago. This was my dissertation project. CRUD apps, fabulous. So we're going to jump forwards 5 years. 5 years ago, I joined Artsy, and when I joined Artsy, we started having a mobile team. And that was the point when we started, doing native code instead of websites, just websites. Of that time period, we shipped, what's this one? This is a portfolio application for art galleries, and we shipped an app that makes it easy to buy and sell fine art on the internet. Did these over the course of, well, this one's still both ongoing forever. But for those first 3 years, I did all of that work on a low-end MacBook Air. It was just a simple computer for building like complicated applications, and everything would just work kind of well. But this entire like situation generally changed for me roughly about 2 years ago, which very much coincided with the introduction of Swift. The moment that Swift joined our ecosystem, a lot of our tools became unstable, to say the least. We didn't have incremental compilation. SourceKit was renowned for crashing, and we started a new project at that time that was meant to specifically like test out the idea of us using Swift within the company, and to be able to say like, okay, we're confident on the way that this is built and the way that we can like work with these things in the future. And in the end, we really started to struggle with all our deadlines. We didn't necessarily expect it to be as fast as it would have been for us to build an Objective-C. But we got to a point where we had a very large amount of problems, and we only managed to find one really useful solution. And that baby was this. So like every single developer on that project ended up getting a Mac Pro. And on top of that, every single iPad, our fleet of iPads were all upgraded to the like iPad Air 2s at the time. Like we were previously on just normal iPads. No, what's a normal iPad? We were on like an iPad Air 4, I think, iPad 4, Retina 4, I don't know. But we all had to update all of our software and all of our hardware in order to just like ship a version of Swift at that time. And that's fine. Like these things, the Swift language improved, the tooling got better, and eventually we came to a point where we felt that maybe it was worth trying to integrate some of the Swift stuff into our actual main application. We experimented with this first by converting our application to stop using static libraries through CocoaPods, but start using dynamic frameworks. And we're very much, well, we don't believe in not invented here. We believe strongly in the idea of, we had a really great quote for this, but I've forgotten it. Using other people's software as much as possible and improving it as much as possible in order to not do our own stuff. And what this ended up happening was that we actually had, like, I think 50-odd dynamic frameworks inside our application. And in the switch from being able to, like, in order to use frameworks so we could use Swift, we had to like deal with a very serious ramification that all of our beta users were like instantly getting crashes when they tried to load the app, because the apps were taking too long to even load because of, well, the app launch times, because of code signing. And these are all like not strictly problems with Swift, but problems that end up happening because of tools that are having to make changes related to the ability to ship Swift. We eventually allowed it into our codebase and started to find that it was like very negatively impacting our incremental compilation abilities. So one of the fixes that we had is one of the tools that we built called Danger now tells us every single slow function to compile from the Swift compiler. It outputs this stuff. So we can know like what parts are really starting to slow our build and dev cycle down, which helped for the first few pull requests. We started doing it, and now it just does it every time, and we always get the exact same results because no one's going to go and fix it. But it's nice to know that like these pods, well, Swifty.json and our WebSocket just happen to be the core things that are slowing down our application's compile cycle. Okay. What's this? 6 months ago. All right, 6 months ago. We're getting close to real time now. 6 months ago, we at Artsy were going to ship a very complicated piece of software. It is a live auctions software. So imagine when you think of like some rich person buying an artwork, there's the person showing it up here, and there's someone with a hammer, and they're like, tsh. We were taking that and turning that digital. So it needed to be like real time. It had to be very correct, because the amount of like the price of those works is pretty obscene. As someone who doesn't pay that much for art, so we opted to use Swift to give it a shot for another try to see if we could get some, like maybe the tooling has improved, maybe we'd got to a point where like some of the trade-offs were actually worth it, totally fine. So we tried it with, functional reactive programming with a hint of WebSockets, yeah, I've already talked about that. And we felt like it was getting mature. There was incremental compilation, and when we started comparing it to the website that was building it at the same time. So this is like a non-trivial like view controller, multiple view controllers, that we were trying to do that was emulating something that the website was doing. And in the end, we just found heartbreak. We couldn't keep up with the web project. We were trying to ship at the exact same time as them. They had to not just build the front end, but they had to build the back end, the admin user interface, and we only had to do all I showed you there. But at the same time, we were slowing down the rest of the team, because every time an API change had to happen, that had to be consolidated down to native, but the actual people building the APIs didn't know how to do any native code, so they didn't make those changes, but they did for the website. So you would have all these like versioning issues between an API, a WebSocket API, and like the actual native app. And these problems just started compounding and compounding. And we'd always, in the mobile team, always like accepted the idea that we would never keep pace with the web. We'd always tried to use like literally a hybrid approach where we present a view controller that pretends to be the mobile web page if we don't support a specific like route from the website. But that wasn't really an option in this case because like the experience that we were actually selling to the auctions that we were selling this kind of software to, like we promised them the kind of expectations that you would get from a native app. And so like midway through this project, I started to get to a point where I was just like giving up on the ideas of maybe even being able to ship it, and that we may just have to like start exploring other things. And luckily for me, I actually ended up finding something that really started to change this around a little bit. This is a tool called injection for Xcode. So if you see here, we're typing in some text. Every now and again, you'll see a little blue flicker up here. And that is the entire of the changes for this application being like compiled and then re-injected into this app at runtime. So you see me changing that, and it was too fast for it to even happen, and then it just makes a new change. This is not like John's demo earlier, where he has a JSON file. That JSON file is reinterpreted, and the app just like recreates a layout at runtime. This is like a full compilation of that Swift code that you're seeing on the side, the actual view controller that's getting injected into the app at runtime. And then all it does is it just pushes and pops a new version on, so it shows it. So it's easy to demo. And this was fascinating for me at the time. It was genuinely, it genuinely changed my perspective. I'd got to a point where I'd known about this project like ephemerally for many, many years, but had never really sat down and studied how it worked or ever really considered that this should be part of my workflow. And like thinking about this over a period of time, really like it came to a point where I realized that I was stopping enjoying actual native development anymore. And like I was finding that it was taking too long to do the work that I wanted to do. I was finding that the language wasn't built in for the types of apps that I was trying to build, and it was genuinely frustrating. And I'm very rarely frustrated with technology because I try to be optimistic, but it got to a point where like seeing this tool that made it so easy for me to use, that has been around for 5 years, that like Apple hasn't tried at all to improve for everybody else. Like it's just a guy doing it on the side. It made me feel like a lot of the time that I had spent waiting on compilation cycles or having to say no that we can't ship this thing because of the slowness of our build cycles. It made it feel like it was all wasted. That I had spent a lot of time not being at my optimal speed. Whew. Okay, so that's the lowest we're gonna go on this talk. We'll be going back up there soon, so don't worry. Okay, so because I want you all to use this, because this is like a really great tool, I'm going to give you an explanation of how we integrate it and what it does. So this is injection for Xcode. It's an Xcode plugin, so you still have to use Xcode 7.3, or you have to use you have to unsign Xcode. But it's really interesting because all it does is the way we integrate it with our applications, it sends you a new version of your objects, and then it sends you a notification. We just listen out for that notification, and then we have a receiver for the notification, and all it does is it just pops the current view controller off the top of the stack, and then runs a thing called developer extras. Developer extras is this it's like a file that we have. It's a category. We have a Swift version too. It's in git ignore, so each developer can write what they want in there for their specific use case. Doesn't get shipped with the app. And every time you run injection, it will push off the current view controller. In this case, it will route for artwork Glenn Brown. It will ask the switchboard to get you a view controller. The view controller will just get pushed into the stack. So every time you press inject, it will get the current view, or get whatever you're working on, put the new version in, pop something off the stack, pop something new onto the stack. It refreshes it. So I'm going to show you what this is like. I'm going to press start, and then the first thing I do here is just do a normal incremental build by just changing a single string. So I pressed it now, so it's building. People on stage so far have managed to say things like, it takes minutes to take a build. Someone told me it takes them like 5 minutes almost for an incremental. Like, for me, the idea that 16 seconds, which is how long that takes, is too long. I couldn't even imagine what it would take to do like 3 minutes, like standing there waiting, like Christine mentioned. And so this is how it works. So we've already injected it, I think, yeah. And now you can see I'm making changes to the text around here, I think. And a new version just got injected instantly. Like, you can barely tell because the little progress bar goes across so fast that it compiles it, injects a new version in. And like, my iteration cycles have just gone back to like a reasonable level of under a second to start seeing changes inside the native code. And that's what saved my ability to like still enjoy some of these actual native programming. So I'm not someone that likes to just gloss over all the details. So I wanted to get a good sense of like how this worked, because if I could understand how injection works in this stage, I could start maybe building tools myself that could do that kind of thing. So I started with understanding how the Xcode plugin works, dug into figuring out that what the plugin does really is it just tries to keep track of every time you press save. It tries to know all the files that are there, and so it will then say, okay, so the next time you press the injection button, these are the things that we need to inject. It will then use a terminal command to actually throw in a small Xcode project that only will compile just the single file that you've said that needs changing. They get compiled into like an NS bundle. Those NS bundles are then passed into your app. So it keeps a WebSocket between your app and the Xcode plugin that is used to transfer these actual like folder structures of code and resources. And it will then load it. It will then, and loading process is really easy. It's like anytime you use like an extension or a nib, it has to run some executable code. So effectively, it's just like easy stuff for Objective-C stuff. We'll get to that later. And then the server will look for the new versions of the existing objects and say, hey, you've been updated to this new version of the code that you've wrote. And then everyone gets an NS notification that you can do whatever you want with. And in our case, we pop off the last view controller, pop on the new one, and life's good. OK, so as with everything, this is not perfect, and that's totally fine. It does not work if you're a Swift purist. So if you only believe in using structs and that like everything needs to be done inside closures, and it's the only way, I'm not sure protocol-oriented programming works well with it either, then guess what? You're not going to be able to use injection. But we found that we could work around a lot of these these problems. Like, it was worth using classes simply for the speed at which you can work. And if you care strongly, once you're happy, you can switch it back to a struct. And then, Apple made it very difficult for people to build their own, fix their own itches in Xcode as of 8. So it requires unsigning if you're going to use it on Xcode 8, which is a process, and it's also not that great of an idea. So that's Xcode. That's injection for Xcode. Interesting project. I started thinking a little bit about this idea of I effectively gave up on the idea of being able to do TDD, native development anymore, since not every single unit test build required rebuilding the app. So it was like 16 seconds to just build the app, and then as long as it takes to compile the unit tests. So the ability to continually get feedback from your tests became very difficult. So I started working on something that would take the ideas from injection and start applying it to tests. So like instead of your tests being something that starts at the top, runs through all the tests, and then finishes and closes the application, it would actually stop the closing process, and it would keep this process running so that you can actually inject new tests into your testing structure at runtime. It's still a work in progress, and I haven't touched it in a few months because I don't do too much native code at the moment. But it's an interesting space that someone else can definitely take over and fill if you are really into testing and you're frustrated by the amount of time it takes to do that. Like the technology behind injection would work really well for testing. It's just that no one's got there yet. So a lot of this kind of comes down to this, all of our reliance on this one major tool as iOS developers, which is not a big surprise that everything relies on Xcode, and all of the choices that Apple make actually have large ramifications on all of us, regardless of whether we choose to adopt the technology or not. And we used to be in a position where we could fix our own problems. This is my favorite trivial Xcode plugin I built, which if you happen to fail a build 3 times in a row, then Shia LaBeouf will come on and be like, "Oh, you could do it!" It's really pleasant when you've been working for and you forgot that you had this on, you've got music on loud, and you go 3 failed builds in a row, and it's like, I built it for people that were starting to program and were really frustrated because they just couldn't figure out the syntax, and it was nice to have some positive reinforcement. But we actually have some non-trivial plugins that do real work that I basically couldn't work without. This one here is for a thing called Facebook Snapshots that makes it easy. So you write some tests. Those tests say this is what it should look like. If your tests, the end result of those tests changes, then this lets you wipe across the before and the after and let you decide whether that was the thing you wanted or not. Once I got comfortable extending Xcode, I ended up expanding on that idea. And I have a version of this that also will show you a preview of whatever view or view controller you're working on at the bottom of Xcode while you're browsing through. These are the sort of things that you just will never be able to build in the future. I doubt Apple will give you raw access to the view structure. And so it was disheartening to be able to lose the ability to actually make improvements to your own workflow outside of outside of things like CocoaPods or Fastlane, but big Ruby projects that you have to use from the command line. And there's a lot of people building critical tooling that is just every year has to start again and try and figure out how do we make this work this year. And that's frustrating, to say the least, for someone that builds this many tools. And I find that a lot of these problems come from the fact that Apple will have their own opinions about what everyone should be building. And a lot of the apps that we are making are effectively things that take JSON down from the server, convert that into a user interface, and I don't think that Swift is a good language for doing that. Objective-C is an okay language for doing that. And this is some of these things because it's a type-safe language. Most of the data you're getting in is unstructured data, so you spend a lot of time taking this data, turning it into native objects, taking those native objects, presenting them onto a screen in a way that works, that you have all these different strange translation layers that in theory, Apple could actually start building API kit, tools that expect you to be using JSON data that would make it significantly easier to take data from somewhere and pass it onto your front end. Mac development has that. We have just me on the Mac development stage. Mac development has it so that you have some data and you can just say in the interface how it all should reflow into your app. These were things that are just never moved to iOS because assumably these are these stringly typed types of techniques and the dynamic programming things are just going away. And in a few years, Swift will have good solid replacements for them probably, but we're not living in a few years, we're living in right now, and we've been having to deal with this for a while. So I ended up getting to a point where I was pretty frustrated, but luckily for me, someone else at Artsy was taking a stab at a few of the alternatives to like building Swift in our applications. We'd always had an opinion of trying to help other projects as much as possible in the open source realm. So like I've taken over the 2 Objective-C test runners, for example, like obviously with CocoaPods. And like in all of these cases, this is not like embrace, extend, extinguish. This is like, we need to use this because this is a dependency of ours. And so we want to have enough domain knowledge to be useful in it. But we could never have a fork of UIKit. We could never have a fork of Foundation in order to make things work. You couldn't realistically have a fork of Swift either, because like Apple will only allow you to ship with the version of Swift that ships with an Xcode. So you would have, if you didn't agree with a single decision and you wanted to have your own version of the language, it's not really an option. And so we started thinking, so someone else did all the thinking, and I just agreed to go along with the ride at first. And we ended up moving we started a bunch of new projects using React Native, which this is not a talk that's like all about React Native, but it is a little bit about it because it became like a part of an answer for us, and like a part of like my personal like understanding of what I want to do with my time as a programmer and where I want to be like working in what communities I'm interested in. So we had always struggled to build view controllers in like a component-based way, to use the terminology that's been going on all day. We had always been building one-offs that used a lot of very specific types of code, and it was very hard to be able to reuse bits of the application, bits of view controllers between different view controllers, because they all seem to always have this one little thing that made it really hard to then start making it generic. And when we did try doing it generic, it ended up being overly generic and very hard to use in like 2 places instead of 1. And so we explored React Native. And the original pitch for why we were doing React Native from Alloy, who's an engineer at Artsy, was that like, at the core, he didn't like this one concept, which is that we would have web engineers, we would have iOS engineers. And the 2 would never share ideas. We would never, like, on iOS, we had like very different verbiology, we had very different ways of discussing problems, we had very different approaches to how we build things. And there was very little cross-team discussion, very little ways of which we would try and like agree on a single like standard between things. Like, because iOS was always behind, we just copied whatever they did when it became to like API requests or what routes we should have in our application. And like, as Christine said, like most of these times that people have moved to React Native, it's because the mobile team has felt that they would do better by using some of the web technologies in their applications. And so we ended up moving to React for a bunch of our view controllers, which gave us the ability to share ideas. It gave us hot reloading, which it's like injection on steroids. And really interestingly, it gave us an open tool chain. We have forks of, we don't have a fork of React Native anymore, but we've like been able to fix our own problems, use our own forks of React Native for, scroll view bugs, or whatever kind of problems that have come up. We have the in-house engineering skills to be able to go and fix these problems, and we actually can, and so we do. And so we have this like abstraction layer that gives us the ability to actually ensure that our tool chains will work for us as well as whoever else is going to have the same problems we have. And that's been like super freeing for us. So the one project that we do have a fork for is something that I just feel like I need to tell you, because it's just like I struggle to talk about React Native without like talking about this, because it just makes me so excited. There's this concept that's called relay in React Native world that effectively says, imagine if your views dictated what the API request would look like. So here is my application. So I have, let's say, what's that? It's like 1, 2, 3, 4, 5, 6. Six components, right? 6 different little bits of the view. Each one of those can dictate what parts of the data they're going to need from the server in order to render themselves. And so relay is the sort of system that takes all of these different all these different, like, we call them fragments, so fragments of like an API request, and then combine them all into one single request. So what you end up having is this system that would end up making you declare your data, the bits of the data that you need, sending that off to the server, but only sending the exact bits of data you want, and then it comes back in and it fills out all of your interface for you. So effectively what you end up having is no ORM, there's no model code, there's basically no view model code, because all of the views themselves are declaring what bits of data they need, and they have the power to actually transform that into user interfaces. And like the amount of code that we don't have to write is considerable. We could compare like the same view controller from the native version to the React Native version, and they are like, the React Native version would be like a fourth of the amount of code, because they simply only have to declare parts of their API, and the amount of data it downloads is like significantly smaller. And so what we ended up happening was that like apps were becoming, for us, significantly faster, because they were doing much less processing and they were doing much less networking. And at the same time, like, we were getting faster builds. And so like, Relay is a really fascinating technology. Even its caching was really interesting. If it's ever noticed that you've ever like requested some object, it will keep that in a big store. And so when it does that kind of component like lookup for all of the different parts of the system, it will just skip making some API requests if it already has it in its local store. So caching isn't even that much of a problem either. Fascinating stuff. I started looking in quite deeply to a project called VSCode. We couldn't use Xcode for JavaScript, so we had to figure something else out. I know, right? We explored Atom, Vim. Hey, I used Spacemacs for a while. Emacs, I think that's it. No, Spacemacs, I think is how you pronounce it. But I found that the VS Code actually is a really interesting editor, in part because I have this pull request that's been going on for like months that actually redesigns the entire like user interface if you're on a Mac. But here's the thing: could you ever imagine someone saying something like that for Xcode? So like the freedom of like me being able to interact with Microsoft over this long thing over like an open source project has been like really gratifying from someone that's come from such a closed tool chain, such a small like sandbox, to being able to like start interacting with like very large companies like honestly, and from a kind of like peer-to-peer rather than like an Apple engineer who would say, file a radar, maybe you'll find out if your thing is fixed in a year. Like being but being able to like actually work on your tools. I now have a considerable knowledge about the internals of how Visual Studio's code works because I've done these changes. The only way that I got internal knowledge about how Xcode works is by like hacking into the system and pulling out all the header files and trying to understand the overall structure. Now I don't even know if you can do this sort of stuff. So being able to like actually work on the actual editors that you work on for your day-to-day life is extremely gratifying. And it's been something that I've been really enjoying for my day-to-day programming stuff. So a lot of the time here I've been like, Swift is terrible, Xcode is terrible, Apple is the worst, which is, none of those is true. All of them are great tools, but like, and it's an alright company too. But like, the problems come from the fact that like, what Apple wants is not necessarily what we want as application developers. The things that we want to build may not be the sort of things that like Apple expect you to build, and so the tooling will not be built in a way that works well for the sort of things you're building. We started looking outside of the sandbox, so outside of Apple's like tooling, and found ways in which we as developers can build things faster, can like feel like we own the entire like tool chain, and be able to still feel happy with what we're doing. But I don't want to leave it all on totally negative from the Apple side. Like last time someone started talking about playgrounds, I started talking with a colleague about how like maybe Swift hasn't still come to what he was hoping it was when he was like seeing the announcements. And Joe Groff is an engineer on the Swift team, and one of the things that he said in this tweet conversation is the real thing that really hooked for me, is that like the Swift like ecosystem is still extremely small, and like Apple are still really trying to get to a point where they can start like integrating Swift natively into their actual tool chains and the applications and the tools. So like interface builder works only by passing strings between multiple things. Like Apple probably want to build an interface builder that's as integrated as Playgrounds is with Swift. It's just a matter of time and a matter of priorities. And eventually we'll get better tools for building these kind of things. But they're just not here right now. And I'm optimistic, because a few of my friends have gone and worked at Apple and are in the dev tools right now. And like some of these people are solving problems in the same way that I solve problems, which is like just do it yourself, and then eventually maybe everything will get fixed. But I don't know. So I'm optimistic, but at the current time, I'm still not sure whether it's like gonna fix it for me. So I'm gonna finish it with, you should start thinking about working outside the sandbox. Start thinking about building tooling for other people so that we can all build better things together. And I don't have a third one, so thank you, everyone.